Hello, dear students. Hello. So, dear students, good morning. And we were discussing about metals and non-metals, right? Chapter number 4. And we have completed up to this physical properties of metal and non-metals. And in today's class, we will see about the chemical properties of metal and non-metals. So, let's begin. So, first, what are the chemical properties of metals and non-metals, right? So here you can see chemical properties, which means in the any chemicals, if we are performing any reaction, so with your metals or non-metals, so your metals and non-metals generally can't be reversed, right? Means this chemical reactions are mostly in a forward direction, right? It can't be reversed back, right? Suppose if we have any substrate or any material, and if we do some chemical reactions with this material, so if its properties is getting changed into in different form, so it can't be reversed back, right? In the normal form or in the normal way, we need to perform another experiment so that it can be again regained. So here chemical properties, right, of metals and non-metals we are just discussing here. So first point is that reaction with oxygen means if you have any metal or non-metal, so how these your metal and non-metal is going to react with your oxygen. So here you can see metals react with oxygen to form metallic oxide, right? Any kind of metal which you have, and if that metal is going to react with your oxygen, it is going to form metallic oxide, right? Metallic oxide, which means you can say here this is your nothing but M stands for metal, and oxide, which means M, right? So if you are going to react any metals with your oxygen, it's form metallic oxide. And these oxides are basic oxide because they react with water to form bases, right? Basically these oxides are basic in nature, right? Why? Because when they react with water to form base, means suppose if you have NaOH, if you heard this, right? NaOH. So this NaOH, this is also your metallic oxide, right? Or metallic hydroxide. And when you will react this sodium hydroxide or sodium oxide, it forms base, right? React with water, so it forms base. So this sodium hydroxide is nothing but your base. Why? Because if you have sodium, right, here you can say this is your magnesium oxide, and this magnesium oxide is reacting with your water, so it is going to form your magnesium hydroxide, which is basic in nature, right? This is base, right? This is base. Similarly, non-metals react with oxygen to form non-metallic oxide. If you have any non-metal, right, like sulfur, right, so also oxygen, it is also your non-metal. So if you have any non-metal and when it react with your oxygen, so it form non-metallic oxide, and these oxides are acidic oxide because they react with water to form acid, right? If you have any non-metallic oxide, and when you react that non-metallic oxide with your water, and they are going to form acids, right? So remember these 2 points, right? That when your metal is going to react with your oxygen, it is going to form metallic oxide, and when this your metallic oxide is going to react with your water, it is giving bases. And similarly, if your non-metal when react with your oxygen, it is going to form non-metallic oxide, and when your non-metallic oxide is going to react with your water, it's giving acid, right? So here is the some reactions are given, right? Like sulfur is your nothing but your non-metal, and when you sulfur is reacting with your oxygen, right? Why? Because here we are going to reaction with your oxygen, right? So this sulfur is a non-metal, and oxygen is also your non-metal, and when these two things are going to react, so they are forming sulfur dioxide. And when this your sulfur dioxide is reacting with your water, right? So they are forming your sulfurous acid, and which is your acidic in nature, right? So these 2 points you must have to remember, right? So that it will be uh, understandable to you, right? Next we have reaction with your water, right? If you have any metals, right, and that metal is going to react with your water, or if you have any non-metal, and if your non-metal is also going to react with your water, so what kind of these situations will be arises here, we will see here, right? So first here, reaction with your water. So metal react with your water to form metal hydroxide, right? Remember one thing, if you have any metal, right, and that metal is going to react with your water, so they are forming metal hydroxide and hydrogen, right? So here you can see this is your sodium is your metal, and when this your sodium is reacting with your H2O water, and they are forming sodium hydroxide plus H2 gas, means hydrogen gas. Example, sodium react with water to form sodium hydroxide and hydrogen, right? And this kind of the reaction is very uh, you can say this is the very explosion reaction, right? Because this sodium is highly reactive in nature, right? And when you react this sodium with your water, so it explosively react, and right, with high potential of energy, and um, producing lots of sound as well as heat energy, right? So this is very explosion reactions. And magnesium react with water to form magnesium hydroxide and hydrogen, right? So similarly, if you have magnesium metal, right, and this magnesium metal is also reacting with your H2O, means water, so this is forming magnesium hydroxide plus hydrogen gas. And if we talk about non-metals, so generally non-metals do not react with water, right? Remember one thing, in the previous section we have seen here, that is your non-metal, right? Non-metal is reacting, means here you must have to remember non-metallic oxide, right? This non-metallic oxide is going to react with water, right? Non-metallic oxide is going to react with water, but especially if you have any non-metal, right? So that non-metal is directly not reacting with your water. So this point you must have to remember, right? Okay. Next we have reaction with acid. So if you have any metal, so how these metals are going to react with your acids, and your non-metal, if you have, then how these non-metals and metal are going to react with acid. So let's look at here. So metals react with acid to form metallic salt and hydrogen, right? How this your metal is going to react with any acid? So when this metal is going to react with any acid, they are generally form salts and hydrogen, right? So we'll see about the salt, what are the salt and hydrogen. Example, zinc react with dilute hydrochloric acid to form zinc chloride and hydrogen. See here, this is your zinc, this is also one of your metal, and this is your acid, hydrochloric acid, HCl. So when these two things are going to react, so here ZnCl2, right? So this ZnCl2 is nothing but your salt, right? this is your salt, and this is your hydrogen gas. So you must have to always remember that when your metal is going to react with any acid, they are generally forming metallic salt and hydrogen gas, right? And if you have any non-metal, right, so non-metal do not react with acid, right? As like previous section, non-metal do not react with water, so similarly your non-metal do not react with your acid. Some non-metals like sulfur react with concentrated nitric acid to form sulfur dioxide, nitrogen dioxide and water, right? So even some of the non-metals, right, which are able to react with your concentrated nitric acid, right, to form sulfur dioxide, nitrogen dioxide and water. So this is your sulfur, this is your non-metal, right? And when this non-metal is going to react with concentrated sulfuric acid, right, not dilute sulfuric sorry, nitric acid, sorry, this is nitric acid, right? So when this sulfur is going to react with concentrated nitric acid, so this uh, reaction gives us sulfur dioxide, nitrogen dioxide and water, right? So these are the three possible products when you react your sulfur with your concentrated nitric acid, right? So these points you must have to always remember, because these are the very important point, right? Next you have metal replace metal. How this reaction take place? Metal replace metals means if one metal is very reactive, so another metal can be replaced by then that very high reactive metal, right? uh, as in the classes I have already taught you that about the metal reactivity series. So if you are remembering that metal reactivity series, so you can easily connect with this, that how your metal replace two metals, right? So a more reactive metal replace a less reactive metal from its salt solution, right? Like if you have any metal, right, for example, here you can see this is magnesium and this is your copper sulfate, right? So this copper sulfate is nothing but your salt, right? So this is your salt. So under this salt, if you react to if you react to this magnesium, and this is your another metal, and here copper is also your metal, so this copper and sulfate is your salt. So when you react a high reactive metal, right, with your less reactive metal, so highly reactive metal can replace to the less reactive metal from the salt solution, right? So here this is your copper sulfate, this is your salt solution, and this is your copper sulfate, means copper is less reactive than magnesium, so hence your magnesium sulfate can be formed, and with the replacement of your copper, right? So here you can see magnesium replace copper, right, from copper sulfate solution to from magnesium sulfate and copper. Why? Because your magnesium is very reactive as compared to your copper, so that is why this magnesium is replaced to this copper from the copper sulfate solution. Next, we have zinc replace copper from copper sulfate solution for zinc sulfate and copper, right? Why? Similarly, as like this magnesium is highly reactive than copper, so similarly zinc is highly reactive than copper. Hence, this copper is also replaced from copper sulfate solution, and in the by the replacement of your copper, this zinc is going to adding with your sulfate, right? So this is forming your zinc sulfate, and in this iron, this is the formation of iron sulfate, right? So here iron is going to react with your copper sulfate, right? Because this iron is highly reactive than copper, so this copper is also getting by the iron, right? So iron replace copper from copper sulfate solution to form iron sulfate and copper, right? So here you can see in all the reactions copper is getting replaced from the different highly reactive metals. Why? Because your copper is less reactive than these metals, right? So that is why salt solutions are new salt, metallic salt is going to form in the different reaction, right? So this reaction is generally uh, depending upon the reactivity series of the metals, right? Means which metal is highly reactive, then uh, other one, so they can easily react with the your metallic salt and replace to the less reactive metal in the reaction mixture or in the particular reaction. Okay, next we have, based on the reactivity of metal, they can be arranged in the descending order of their activity, right? So I have taught about the metal reactivity series. You can just remember that metal reactivity series, how this metal reactivity series is feasible, right? So on the basis of that reaction, that metal reactivity series, we can easily conclude that this metal will be highly reactive and this metal will be less reactive, and on the basis of that we can also rearrange all the uh, salt solution and metallic your reagents, or we can say reactions, right? Next we have activity series of metal. So here activity series are given here, right? And so you can also, if you don't know, so you can just write down all these metal reactivity series, so it could be understandable for you. So here you can write potassium, sodium, magnesium, aluminum, zinc, iron, lead, copper, silver, gold, right? So this is your metallic metal reactivity series, right? And this metal reactivity series is very very important for you, because you can see here I have already given some trick to you to remember this metal reactivity series, right? So the arrange of the metal in the descending order of their reactivity series is called activity series of metal, right? So this is actually the descending order, right? Means from top to bottom, this in the top position all the metals are highly reactive, and in the bottom position the metals are very less reactive, right? So that is why potassium is very reactive, then sodium, right? Means potassium is highly reactive, and after that when you go in the bottom side, so the metal reactivity series is going to decrease, right? So potassium is highly reactive, and then less reactive of then potassium is sodium, then less reactive of magnesium, then sodium. So similarly, if you are going uh, to the bottom side, so your reactivity series is going to decrease. So you can also remember by your different tricks, like please stop me calling L as uh, Jepra, right? Instead learning copper, silver and gold. Likewise, you can remember. So similarly, this is the metal reactive series. So your potassium is highly reactive, and in the bottom side you can see here gold is very less reactive, right? So that is why mostly people are wearing gold ornaments, right? Because this is less reactive in the nature. And similarly, some people are also finding due to digging or due to naturally golds in the nature, right? Why? Because this gold is very less reactive, so it can also be found in the nature in the pure form, right? So this is the all about this. And next we have noble metal, right? So what are the noble metal? Noble metal means metal like gold, silver, platinum, etc. remain their luster because they do not react with air, right? So these are the noble metal. Noble metal means the metal which do not react with air, right? In the atmosphere, right? Or with the air, water or acid, so they are called noble metal. Why? Because they are due to less reactivity, they are not going to generally easily react with the any other environmental factors like air, water and acid. So that is why they are noble in nature, right? Uh, and hence we are calling noble metal. Gold dissolve in aqua regia, right? This word you have to remember. Aqua regia means here is the ratio of concentrated nitric acid and concentrated sulfuric acid, right? So the ratio is 1:3, and the mixture of this two acid is called aqua regia. Aqua regia means if you have 1% nitric acid or 1 mole nitric acid, so you have to take 3 mole of your sulfuric acid, sorry, hydrochloric acid, right? So by the mixture of these two, concentrated acid is called your aqua regia. So this gold is generally dissolved in only this aqua regia, right? And some pupils or some uh, that is jewelers, those are making any gold uh, ornaments, so they are using this aqua regia for dissolving this gold in the particular uh, solution medium, right? By that way they are usually separating this pure gold from their any mixture or from their impurities, right? So this is the your ecoregia. And you are also knowing about the pure gold, right? So I think you have heard about the pure is 24 karat gold, right? And so international, this is the you this is the standard, right, to measure the gold, right? So pure is 24 karat gold. It is very soft and cannot be used for making ornaments, right? So if you are thinking that the golds which you are wearing, right, so that is pure gold, so that is not your pure gold. Why? Because pure gold is 24 karat and it is very soft and cannot be used for making ornaments. Because if you will make this by using 24 karat gold, so that gold will be very soft and it can be broke, right, or it can be broken, or it can be uh, break down by easily uh, movable things, or you can say by pushing or pulling, right? So it can be breakdown. So that is why uh, jewelers are going to mix these pure gold with the silver or sometimes copper to make hard it, right? So the ornaments which you are wearing, that is looks like hard. Why? Because that ornament is mixture of your either silver or your copper, right? And you are not wearing pure gold. Why? Because pure gold is very soft, right? This can be easily broken. Next you have use of metals, right? So what are the use of metals and why these metals are very uh, important for us? So first thing is, here we have to note down that the metals are very useful things for us, right? As you are looking in our daily life, various kind of the things which are made up of your metals, right? Either your houses and your door or your kitchens utensils, so mostly the things are made up of your metals. So that is why these metals are very very important for us to understand their properties and their uses. So first, about iron, various uses are given here, like pins, right, nails, nuts and bolts, tools, machine, construction of building, bridges, etc. So these are the some uses of the your iron. And similarly, uses of aluminium, it is used for making utensil, right? Some of the utensils are making by the your aluminium. Wires, furniture, parts of aircrafts, vehicles, machine for packing foods and medicines, etc. Similarly, copper is used for wires, vessels, electric gadgets, etc. And if you talk about the gold, so gold is for making jewelry, coins, medals, etc. Silver is used for jewelry, coins, medals, etc. Coins, coins which you are uh, using for buying something or giving to the shopkeeper and uh, buying something from the shops, right? So these coins and medals, right? Medals are also giving in the your schools, colleges and different placement. And platinum is also very useful for us. And platinum is used for making jewelry, electric gadgets, right, like a wall and a wall watch, or you can say that is the clock. And similarly some electric appliances, right, and plug and vehicles, etc. Sodium compound are used as common salt, chemicals, etc. So sodium is also your metal and which is used as a common salt, right, which you are taking daily in your uh, food, right? And next we have that is your calcium. Calcium is also very important for us. Calcium are used for making cement and glass, etc., right? So the factory which are made up of for production of your cement and glasses, right? So they are generally using this calcium. And calcium is nothing but only your these things, but these are also very important for our food, right? Sometimes we are using this calcium as a uh, different, like milk we are using, right? So in the milk also calcium is present. So uh, ingredients are different food items, some of the elements or some of the metals are also present, and which are very important for our body and for our food. Next, about the your use of non-metals, right? So here, till now we have seen about the use of metals, and now we are discussing about the use of non-metals. So why these non-metals are used, and what are the importance for us? So sulfur is used for making sulfuric acid, salts, and metals, etc. Right? Salts of metal, right? With sulfur making sulfuric acid, as you know, in by doing for different experiments, sulfuric acid is very important for us. And salts of metals, etc. Means if we are going to make any salts of metals, so this sulfur is very important for us. For example, if you have H2SO4, right? So if you have H2SO4, and when you react with this your copper, so this will be form your copper sulfate. So similarly we have different acids which are used for making your metals, salts of metals, as well as in the different chemical reactions. And oxygen is used for respiration for by living things and burning of fuels, right? So oxygen is also your non-metals, and which is used for your respiration of living things, right? Like your animals, right? Like we are also breathing our respiration, and burning of fuels, right? So as you know, that is oxygen is very important elements for burning of the fuel, right? Means to catch fire of any material or any substance, oxygen should be presently there, right? That then only fire can be catch, otherwise there could be no fire. And nitrogen is used for making ammonia, which is used for making fertilizer. So nitrogen, you know, this is used for making ammonia is very commonly used material, right? And which is used for making fertilizers like urea. So urea is also made up of your nitrogen containing some substances or materials. And now we have hydrogen is also very important for us. Hydrogen, you know, hydrogen is used for that is your uh, welding, right? So used for making ammonia, and used for making fertilizer as fuel in rockets, and for welding, right? So in different purpose hydrogen is used, right? For making ammonia, used for making fertilizers, fuel in rocket, right? As a in the rocket, right? This hydrogen is used as a fuel. Hydrogen fuel is very uh, powerful fuel, right? And as well as for welding, gas building, you know, so that is hydrogen gas is used. And similarly chlorine is used to kill germs in water, right? So if you have any dirty water, and if you want to drink that water, so you can just use this chlorine tablet. And if you will put that chlorine tablet, so in the water, all the dust and all the dirt can be uh, decanted in the bottom portion, so you can easily filter that water and used for your drinking. And this chlorine is nothing but only used for your uh, filter the water, but also kill the germs. And as you know, that is the bleaching powder, right? COO Cl2, right? So that is the uh, chlorine is also used in the bleaching powder, which is also used for cleaning the water. And iodine is used as tincture, right? Tincture, you know, when some people are getting hurt or or any injury, so they are using this tincture iodine, which is an antiseptic, right? So these are the some non-metallic use, right? And iodine is also very important for us, as you know, that is the in our common salt. So this iodine level should be maintained, so people can't be uh, deficiency of your iodine, right? Because the level of iodine should be maintained in our body. And you know, due to deficiency of this iodine, goiter disease is caused, right? So uh, to remove or to control the goiter, people should have to maintain in their body the level of your iodine. And next we have the alloy. Alloy means when you mix two or more than two metals together, so then alloy is going to form, right? So here alloy can be your homogeneous mixture, right? Why? Because metals are generally same state, right? Like all the metals are generally exist in the solid state except your mercury, right? As in the previous classes we have seen. So an alloy is a homogeneous mixture of a metal and with other metals or non-metals. So here you can see this. Here is some list of your alloy, right? So like your steel. Steel is a alloy. You have heard about this steel, and how this steel is going to form. So by the mixture of your iron and carbon, right? When you will mix this iron and carbon to form your steel, and this steel is very very important for us to make your utensils and construction of tools, machine, tank, vehicles, shipyards, rail, buildings, bridges, dams, etc., right? And next we have stainless steel. So stainless steel is made up of your iron and chromium, right? With the mixture of these two things we are getting just stainless steel, and this steel is used for utensil, and that is the your uh, cu- uh, culture and surgical instruments and etc. Means various items are also made up of your utensils, sorry, stainless steel. And next we have brass. So this brass is made up of your copper and zinc, right? By the mixture of this copper and zinc we are getting brass. Utensils, handicraft, musical instruments, etc. can be formed. And bronze, right? This bronze is made up of your copper, tin, right? So this bronze is nothing but your uh, a normal alloy, right? So it is actually bronze is made up of your copper and tin, and this is a bronze alnico, right? So this copper, tin, iron, aluminum, nickel, cobalt, with the mixture of these groups, right, we are getting this bronze alkino, sorry, alnico. And use of this bronze alnico is statue, right? Some of the statues are made of this bronze alnico. Medals, bells, ornaments, etc., making of magnets, right? So some magnets which are used in the uh, musical instruments, right? So that is also used for your magnets, right? This can be made up of your bronze alnico alloy. Next we have duralims. Duralims are made up of your aluminium, mixture of aluminium, copper, magnesium, manganese, right? And this is used for your making utensils, right? Different utensils which are used in our kitchens and pressure cooker, parts of vehicles, right? So like motor car or any heavy vehicles and aircraft, etc. So all these are the some uses of the different alloy, right? And which can be made up of different constituents, right? So I think you are clearly understood about these things. And next we will talk about the corrosion, right? So corrosion is very important for us, and this corrosion can cause the destroy of your materials, right, or destroy of your metals, right, and which can reduce the life of your metals. So how you can control these metals and their lives, right? So corrosion, the surface of some metals gets corroded when exposed to moist air for a long time. This is called corrosion, right? As we have seen in the previous section, that is the some noble metals are given there, like your silver, copper, and your gold. So these are the some noble metal, but other than that metal, mostly metals are getting corrosion are corrosed from the moist and air, right? For if that metals are kept in the longer time, are exposed to the longer time for moist and your air, so they are getting corrosed. So prevention of corrosion of metal is very important for us, so that we can uh, increase the life cycle of the metals, right? So the corrosion of metal can be prevented by applying oil or grease, right? So if we applying oil or grease over the surface of your any metal, so definitely we can control the corrosion, right? Second thing, we can apply paint. And third, that is the paint, that is the painting of the uh, your metals, right? Different colors are varnish, right? And galvanization, this is very important for us. This galvanization is also called your coating of metals, right, with non-metal non-corrosive metal like zinc and chromium can be used for the galvanization, or it is also called your electroplating like the things. So these two things are very important for us. And electroplating coating of metals with non-corrosion metal like chromium tin bypassing electric current, right? And here alloying, right? Alloying is also one of the important thing by which we can also control the corrosion, right? Or we can also prevent the corrosion from the environmental moisture and air. So alloying, as you have seen here in the previous section, that like by making of your steel or stainless steel or alnico, that is the your bronze, right, and brass. So these are the different alloys. So if you will make different alloys, so these alloy are resistive in nature towards your corrosion, right? So that is why your alloy is very useful for us. And when iron is alloyed with chromium and nickel, it forms stainless steel which is resistance to corrosion, right? So some of the important factor are given here. And next we have activity to show the that air and water are necessary for rusting of iron, right? So this activity will show you that how your air and your water is necessary for rusting of iron. Rusting. So rusting means some your pure iron is getting converted into iron oxide, right? So that iron oxide is nothing but your rust, right? And this rust can uh, uh, cause the or decrease the lives of your pure metal, or it can destroy to the metals, right? So here you can see this reaction or this activity. Take three test tube. Here three test tubes are taken, right? And test tube, put one iron nail in each, right? In all these three test tube, one iron nails are putted here, right? And some anhydrous calcium chloride in one test tube to be absorb moisture, right? So here one anhydrous calcium chloride, right? Anhydrous means calcium oxide is taken here. And pour some boiled water, right? In the pour some boiled water which dissolved oxygen has been removed in the second test tube. So here your hot water are taken in the second test tube, and pour some water in the third test tube, and here normal water is taken in the third test tube. And cork the test tube, means over the surface or over the mouth of the your all the three test tube cork are kept over the mouth, right? And leave for 3 to 4 days. It is seen that the nail in the first and second test tube have not rusted, right? So it is seen that in the first and second, this is first and this is second, these two test tubes are looked after 2 or 3 days. They are uh, simply looked like previously kept it. But if you clearly see the third test tube, so here your third test tubes in the your the nail which is kept here, so that is getting oxidized, right? And the nail of your third test tube is getting rusted, right? Why? Because here normal water has reacted with your nail, and it is formed your iron oxide, right? So these are the some reactions and which are very important for us. Means if you put any normal or any nails over in the expose of your moist and air, so definitely your metals is getting rusted, right? And if you will put any boiled water in the your boiled water or your anhydrous calcium oxide, so definitely, or calcium chloride, so definitely that metal can't be rusted, right? Because all the moisture can be absorbed by the your calcium hydroxide, and similarly boiled water, here hydrogen is going to removed from this hot water or boiled water, right? So these are the some reactions, and if you have any doubt or any questions related to this chapter, so you can just ask me, and in the WhatsApp, as well as you can also drop your comment on the chat box, right? So finally we have completed this chapter, and in the next class we will talk about the chapter number 5. So till then, take care, bye bye.